Hello and welcome to this episode of Solar Expedition. I'm Mike Johnson, Sales Manager for our Hermitage, Pennsylvania campus. Today we're going to be discussing stress relieving. You know, we get many questions about how much will my part move? How much distortion should I expect? These are very difficult questions to answer. Did you know in the machinist handbook stress relieving is called out more than 20 times? Yet it is a process that is avoided. During today's discussion, you're going to see the anatomy of a good stress relieving cycle that I believe will help minimize your distortion concerns. Let's go.
We have two methods in which we can stress relieve. One of them is air stress relief. Most economical, by the way. Air stress relief is good for parts that have stock on them and will go through additional machining processes. You can expect discolorization only. No scale typically. For parts that are finished machined or have areas that will not be remachined after heat treatment, vacuum stress relief is preferred. This process is also recommended for reactive metals like titanium. Once we know a little bit about your manufacturing plan or process, your solar salesperson can recommend if air or vacuum is needed. During the next couple slides, I'm going to discuss thermocouples, or as we say, TCs. See circled red in this picture. You have control and overtemp thermocouples, or TCs, in the ceiling of the furnace. And part thermocouples are attached to the actual part itself. We call these work thermocouples, or might be referred to as work TCs, part TCs, or contact TCs. Basically, at the end or the tip of these wires, we are measuring the actual temperature of the part. Measuring actual part temperature is very important in having a successful stress relief process. Here we have a part that has been machined, welded, cold formed, and has surfaces on the inside that will not be touched after stress relief, or heat treatment for that matter. Vacuum stress relief was the only option for this part. No oxide or discolorization allowed on any surfaces. As you can see from the cycle description, this is far more than just taking a part up to 1250 Fahrenheit for 2 hours. Please note the ramp rates, thermocouple differentials, and cooling rate instructions. The customer on this part was very descriptive of where they wanted the part thermocouples to be placed. Some were on the inside and outside of the part, and on the thickest and thinnest areas of the component. On the 8 thermocouples, note the 75-degree max differential. Also note that we want to make sure that the furnace does not get too far ahead in temperature versus the part. This could cause unneeded stress. So we built in that no more than a 250-degree Fahrenheit differential between the control TC, the furnace TC, and the part thermocouples. Starting at ambient, very important. Loading into a preheated furnace could expose the part to thermal shock. This preheat at 300 degrees Fahrenheit is not always necessary. However, it does give us a good indication on how the part thermocouples will track and hold at temperature. If you have a problem now, you can abort the run and check your thermocouples. Perhaps one pulled out of the part. Perhaps you have a bad thermocouple. Or maybe something is wrong with your thermocouple jack panel. So now we are ramping up the temperature, knowing that we have a maximum ramp rate we cannot exceed. On top of that, we are making sure that the furnace does not get too far out or hotter than 250 degrees Fahrenheit than the part temperature. Slow ramps and thermocouple differentials are key to not causing stress. Here we are actually slowing down the ramp rate and creeping into our 2-hour soak. Now we are furnace cooling at a controlled rate of 130 degrees Fahrenheit per hour, being mindful of the TC differential over 8 thermocouples and making sure the furnace thermocouple does not separate more than 250 degrees Fahrenheit from the work. Once below 800 degrees Fahrenheit, the furnace naturally starts slowing down. You can see this on the chart. That's okay. In this case, slower is better while working our way down to below 450 Fahrenheit. Once below 450 Fahrenheit, you can now backfill with nitrogen or argon and turn on your fans, and cool to below 250 Fahrenheit, where you can open the door and allow it to slow cool to ambient temperatures. Remember this, that nice shiny peeled bar might be loaded with stress before you even touch it. Then of course you introduce more stress and cold work by machining it. Consider stress relieving in your manufacturing process. Who knows, you might lose some stress also.
Hopefully you found this video helpful. Thank you for joining us on our video series, Solar Expedition. Please let us know any heat treating subject you would like to see us focus on. Once again, I'm Mike Johnson. Thank you.